Today I'll be explaining the Gauss linear accelerator. And here before you have a curved track, and it's in a parabolic shape. Now we'll demonstrate the law, conservation of energy. So as we put one ball at the end, of course it has potential energy, and as it rolls down it will gain kinetic energy, and it will then collide with the other ball. Here you go. Now why didn't it reach the other side? Very simple, friction, right? So if we have two at the bottom, we strike it with one, will it overcome friction? As is obvious, it didn't overcome friction. So what if we put two at the top? The same, right? And we'll do three. Many would think that this would have enough mass to gain enough kinetic energy that would then allow this ball to go off the end. But we will see the reality. It doesn't, okay? And these are just regular marbles. So now we're going to do the same concept with 4 steel balls. Okay, so here we have 3 of them. Here we have another one. This is the ball we're going to use as the driver, or the one that's going to hit the other ones. And here we have a neodymium magnet. Okay, so we're going to place a magnet alongside the other steel balls. Okay, and we're going to use one ball, our driver, off the end, and you will see 2 things happening. You will see this ball's potential energy turning into kinetic energy as it slides down the ramp, and you will see it gaining magnetic acceleration. Now, why does this happen? Because there's such a thing as a magnetic potential energy. As you can see as I put my finger in between the magnet and the steel ball. You can see the attraction there. That is the magnet's potential energy that's acting on this ball. So what does that cause? Kinetic energy. So it causes a magnetic kinetic energy that it gives this ball magnetic kinetic energy. So this energy, combined with the ball's gravitational kinetic energy, combines to cause a massive acceleration that will then allow the last ball to overcome the attraction of this magnet and shoot off the end. So here we go.
Who was Friedrich Gauss? Carl Friedrich Gauss is a prince of mathematics. He was dubbed this for a reason. Gauss's research into the fields of geometry, particularly non-Euclidean geometry, indirectly led to Einstein's theory of general relativity. Einstein's publication of this theory was very momentous. It allowed doubts about gravity to exist and potentially proved Newton's theory wrong. Gauss's focus on planets and tracing their movement encouraged him to look beyond Euclidean geometry and find non-Euclidean geometry. Yet as math built on math, so Einstein built on the foundation that Carl Friedrich Gauss set forth. Thus, Gauss's work allowed people to consider more and more things understandable. People were able to explain nature and math. Therefore, it can be said that Gauss's work contributed to a mathematical revolution. He provided a new world for mathematicians, a world in which the conditions were different and discoveries were to be made. Thanks for watching Harmony Schools.